this video on solving systems with matrices. What is solving systems with matrices? So a matrice is a method for solving a system, and we're going to use the calculator and a 2x3 matrix. And what that means is we're going to have two linear equations with two variables and an answer, which makes the 3. So I have a series of steps here for using the TI-84 graphing calculator. Desmos, you'll have to come to me for special instructions. Okay, to solve a system, we need to make sure that our system is in standard form. Remember, standard form means AX plus BY equals C. So if I look here, I have X plus Y. You need to have X plus Y or X minus Y equals a number. X minus Y equals a number. These are both in standard form. And so we're good to go there. We're going to rewrite the system as a matrix and enter it into our calculator. So here's what I mean. We're going to draw a bracket. And all I need at this point is the coefficients. So that's the numbers in front of the variables, or the constants, just the numbers. So there's a 1 here and a 1 there. We need to be able to remember that there are actually numbers there. So in the same position, I'm going to say there's a 1, and then a 13. And then down here I've got 2 and negative 3. And you see how the y's are lined up over the y's and the x's are lined up over the x's. The calculator understands this as our method. And then this one equals a 1. That is our matrix. And we're going to find out what the answer is. It's going to be a point, because a system of equations have 3 choices for solutions. They're either going to cross at a single point, they're going to be parallel and have no solution, or they're going to be the same line and have infinite solutions. So to put this into our calculator, let's grab those. All right, with our calculator, our first step is the second button and x negative 1. So x negative 1 is right here below the math button. So second, x negative 1, and you should see this menu pop up. We're going to arrow over to an edit, and then we're going to press enter. And we should see something. Yours might look a little bit different. We're going to enter the dimensions of the matrix as 2 by 3. So instead of 1 by 1, I'm going to say 2, enter, 3, enter. So now I should have 2 rows with 3 columns. 2 rows, 1, 2, 3 columns. Now we're going to enter the system as a matrix. That's what we wrote down here. So you're going to take 1, enter, 1, enter, 13, enter. Notice how they're in the exact same positions as the original problems. And then we have 2, enter, negative 3. It's not a minus 3, it's a negative 3. Enter, 1, enter. Okay. Now we have everything put into our matrice. So that's the big end of step 2. Step 3, clear the screen by hitting second mode. So mode is right here next to the second button. It's really so we can quit. Second mode is quit, and we should go to a blank screen. Now we're going to actually solve this system. So press second x to the negative 1 again, so we go back to our matrice menu. Arrow over to math, because now we're going to do some math. We're going to select option B, which is RREF parenthesis. So I like to arrow up, it's a little bit faster. Option B, RREF parenthesis, and press enter, and it should say this information. Now we need to one more time go into second, x negative 1, and tell it we put our information into matrice A, so we just select matrice A and press enter, and it gives us this feedback here. So these last 2 numbers are our system. That's our answer. The top number is x and the bottom number is y. So that's our x, that's our y. If we were to graph these 2 equations, they're going to cross at the point 8, 5. Okay, so let's try this again. Let's try number 2. Okay, so we're going to go into second, x -1, go over to edit, enter. You should already be the correct size because we just changed the dimensions. And if you remember, these all have, every one of those have an understood 1 in front of them. So our whole matrix is going to end up, before we put it in, what it's going to look like is 1, 1, 2, then 1, -1, 6, 1, -1, and 6. That's what our matrices should look like once we have our data entered. So we have 1, 1, 2, and then we have 1, -1, 6. Okay, we're going to quit. Second mode will get us to quit. Okay, now we want to go back in, second x to the -1, go to math, arrow up to RREF parenthesis, press enter. We got to go back into matrices to tell it we put everything in matrices A. So we select A, and we're going to press enter, and we get a solution here of 4, -2. So we could solve this using elimination, we could solve this using substitution, we could solve this using graphing, but our matrices helps us solve it a different way. It's just another way of solving them. All right, there are a couple things that we have to be cautious of. One of them is you will not always be in standard form. You got to have x and y on the same side in order to use the matrices. So this 4x needs to come back over to the number side if we look at number 4 here. So if I subtract 4x from both sides, I will end up, this equation turns into -4x, that's a positive y, equals -11. Okay, so that's just, I needed to rewrite it in standard form. The x's and y's have to line up over each other. So when we go to put this in our calculator, our coefficients will be 2, -5, 19. And then we have -4, 1, -11. Okay, now try pausing the video, follow these instructions, and see if you can get the answer to come up on your calculator. Come back when you're finished. Hopefully you were able to get all your data inputted into your matrix and perform the operation that needed to be done and got the answer 2, -3. All right, so most of these are pretty straightforward. If there's one solution, it's pretty easy. We have to be cautious of when there are no solutions or infinite solutions. And we will see the same thing appear in our calculator window every time that this happens. So let's look at number 5. We have x's over x's, y's over y's, constants over constants. So we're good there. Our matrices will be -4, -8, and 23. And then remember there's a 1 there, 2 and 13. Okay, so pause the video and get this into your calculator and go ahead and perform the RREF, and let's talk about it at the end. All right, this looks like the answer 0, 1. The point 0, 1 would be our answer, but you need to be very cautious when we're using our matrices. If this bottom row on your answer is 0, 0, 1. What that is saying is 0 plus 0 equals 1. Does 0 equal 1? It does not. That's not possible. So this is no solution. Anytime you have 0, 0, 1 on the bottom row of your matrices solution, that's called no solution. Okay, so in addition to looking at the end, always double check your bottom line here to see if you're actually a no solution. Okay, so let's try a couple more. Flip this page over and we'll keep going. All right, let's try number 8. Now, we have x's over x's, but we do not have y's over y. So notice I have the 3y on the other side of the equals. I need to move the 3y across the equal sign, and I also need to move the 42 across the equal sign. That's a negative 42, so we'll add 42, which gives us 4x equals 3y plus 42. But we're going to move the 3y to the other side by subtracting it. So we get 4x minus 3y equals 42. Okay, so you just always have to have x and y on the same side, and it needs to line up with the other equation. So our top equation has 8, negative 6, 84. The bottom equation has 4, negative 3, and 42. Okay, I would like you to pause the video, put this into your calculator, and come back once you have your solution matrices. Okay, putting this in, you should have 10.50. This is another one of those, another very important things you have to pay attention to. If your bottom row is 0, 0, 0, as we have right here, that means we're going to have infinite solutions. So what the bottom row is really saying to you here is 0 plus 0 equals 0, which is true. Okay, so this one has infinite solutions. So you're going to look for the two left numbers. No, sorry, the two right numbers for your solution. But you always need to check the bottom row. Check the bottom row. If you have 0, 0, 1, that is no solution. If you have 0, 0, 0, that is infinite solutions. Okay? So that's what you got to keep in mind while you're doing these, because they can get kind of repetitive because you keep doing the same button pushes, but pay attention to your answers to make sure you're giving me the correct answer. Now let's try a couple word problems to see how it works the exact same way. So in these you have to write the equations and then we'll solve them. So if we look at, let's try number 11. Two families go to a hockey game. One family purchases 2 adult tickets and 4 youth tickets for $33. Another family purchases 4 adult tickets and 5 youth tickets for $51.75. What is the cost of an adult ticket and the cost of a youth ticket? So anytime we're writing our equations, we need to define our variables. I'm going to use x and y because it helps you write the point at the end. Because I usually pick them in the order they're given. So adults were mentioned first, so that's the adult ticket, and y will be the youth ticket. Okay? Now this kind of problem, each sentence is its own equation. They say they have 2 adult tickets plus 4 youth tickets, and they spent $33. The other family purchased 4 adult tickets and 5 youth tickets, and they spent $51.75. So doing that, I have my, these are actually x's because I accidentally wrote A for adult. I have my x's over x's, y's over y's, constant over constant. So I can make my matrices here. I have 2, 4, 33. Then I have 4, 5, 51.75. Okay, go ahead and put that into your calculator and come back when you're done to see how you did. All right, so I have 4.75. What does that answer mean? What that answer means, if you go back to the problem when we defined our variables, that means the adult tickets are $7 and the youth tickets are $4.75. All right, let's try this again for number 12. See if you can set up the equations and solve it and come back to me when you're done. Before we get to the final answer, let's see how you did setting up this problem. So we have Bob has 60 coins consisting of quarters and dimes. The coins combined value is $13.35. How many quarters and how many dimes does he have? So we know he has a total of 60 quarters and dimes. So if I define quarters as X and dimes as Y. So if I add together my quarters and dimes, I got 60 coins. Then we start talking about the money. He doesn't spell it out here, but you know how much a quarter is. A quarter is 25 cents, so 20.25 times each quarter, plus a dime is 10 cents, so 0.10 times each dime. How many dimes? Gave us a total amount of money of $13.35. So when I put it into my matrices, I got out for an answer 49,11. And what does that mean? That means that Bob had 49 quarters and he had 11 dimes. Okay, so I'm going to help you set up this next one. This one we kind of struggled with the first time we did systems of equations. And so it's a matter of getting used to reading the problems and knowing what they're asking for. So the next algebra test is worth 100 points and contains 35 problems. Multiple choice questions are worth 2 points each and word problems are 7 points each. How many of each type of equation are there? So we have two kinds of questions. So the first one mentioned is multiple choice, so I'm just going to call multiple choice X. And the Y will be the word problems. Okay, so I have points and I have numbers of problems. If I take my multiple choice questions and my word problems, I have a total of 35 problems. So I just say multiple choice plus word equals 35 problems. Now when we start talking about points, the points have to equal the points. We know that the multiple choice are 2 points each. So 2 times each multiple choice question. Plus the word problems are 7 points each. So 7 times the number of word problems gives us a total of 100 points. So we got points, points equals points. Problem type plus problem type equals total number of problems. Okay, so our matrices here would be 1, 1, 35. Then we have 2, 7, 100. And you should be able to go from there and get your answer and figure out what it means. Hopefully this was helpful. Let me know if you have any questions. See you in class.